Welcome everybody to Greenplum Chat. I think we're up to number 9 now. Today's topic was how to query and update external tables based on AWS S3. Our expert in the hot seat today is Ame Banars. And so Ame is a data engineer with Pivotal with experience in engineering and delivering enterprise-wide solutions directly impacting line of business for finance, regulatory compliance, and pharmaceutical clients. What's the best part of his bio is the fact that he's actually an AWS and GPDB expert. So I'm quite excited to hear what he has to say about the new capabilities of GPDB to work with external tables in AWS S3. The rest of the panel here is Ivan Novick, product manager for Greenplum, Jeff Kelly, data evangelist for Pivotal, and Dan Besquet, who is director of technical marketing, and myself, who is manages the big data communities such as this one. So with that, Ami, what do you have to share for us today?
Great, thanks for the introduction. So, as a quick intro, let me just set a stage for what S3 is. I'm sure most of the folks on this call already know, but then S3 is like a distributed object store that is available in AWS. And it's distributed in a way that it's available as a single region entity, as well as across multi-data centers or multi-regions in Amazon. And Amazon themselves takes care of, replicating it and then assuring that it's highly reliable. So S3 has one of the highest SLAs as any of the Amazon services. It's like 99.99. And actually there are a lot many more nines up there. So I just rounded it right now. And then it's kind of unlimited. So most of the people use it as a very highly scalable data lake today. So I come from a background where we use S3 as a data lake. We really didn't have a Hadoop cluster. And we would just go spin up Hadoop clusters on demand, grab the data, dump it back to S3 as the output. So that's exactly the design pattern we'll be talking today using Greenplum. And this is one of the features that we've built to ensure that you don't have to ingest the entire data set. You can just do quick exploratory data analytics on data that's at rest in S3, spin up on-demand compute whenever you need, dump back the outputs whenever, for the downstream applications whenever you need it. So with that said, one of the other caveats with S3 is that S3 likes to have, it's like with HDFS, it likes to have, larger files and less amount of files in a given folder or a given directory structure, if you may call it. And with that, the limit is like 5 terabytes per object. But then in our testing and everything, I'll come to best practices point where we have some sweet spot of what this object size should be, just based on our customers who are using it, as well as some internal testing. So that is one other thing that we need to keep in mind. And predominantly, again, it's used for long-term storage. So it's not consistent storage. That means if you have multiple users using the same S3 bucket, they might get a different view of data for a split second or a couple of seconds, however Amazon decides it. So it's not consistent. It's a good thing to remember. So with that, the feature that I'm going to talk about today is the S3 external tables. This has been out for quite a while, but then we timed this presentation because we are releasing the writable external tables feature sometime late this week. So until today, what you can do is you can define an external table in Greenplum and point it to an S3 bucket. And the data in that bucket can be a text or a CSV or any delimited in that sense. And it can be gzip compressed as well. And you just define a table, you start querying it, it's right there. You can go query it, create internal table, dump back the data inside it. You can actually go and do, PLR, PL-Python, MATLAB on this data set itself if you want. But as a best practice, we always tell customers that do your exploratory data analytics on these external tables. And whenever you need to operationalize something, bring it to internal tables, distribute it correctly, partition it correctly, and then run any queries that you need. So that kind of sets you like a really good data pipeline in that case. And without this feature, one of our top customers where I used to help them was we had to load the entire data set from S3 on every single Greenplum node first, then do a GPF test, and then basically kick off the data workflow that I just mentioned. So this feature basically cuts down the data pipeline by about 40 to 50%, just in raw benchmark if you need. That is because I can just say, create an external table with a 10-node Greenplum cluster on this S3 bucket, and it just starts querying it. So there is no real magic behind it because it's all engineering, and it's a brilliant engineering, by the way. So I'll go a little bit under the covers to give you guys a flavor of how the engineering behind this looks. Again, this is all open source, so feel free to go browse the code on our GitHub bucket. It is really, really fantastic design in that sense. And to get started with that, this is our typical AWS deployment topology. So you would have the customer network client, which is their own VPN. You would go spin up the Greenplum cluster. Typically, you would have an edge node where you can go and SSH into the nodes, or have users log into that. There's a Greenplum cluster. Again, later part of the presentation today, I'll discuss the best practices for setting up such a cluster. And then you have S3 bucket, which is available for connection to such a cluster. So that means that you would go open up your firewall ports and security groups in Amazon to make sure that the connectivity is all good. And with that, in such a topology, what happens is that each of the Greenplum hosts and each of the segments inside that Greenplum database would actually go and communicate with S3 bucket individually. And this is the difference how we implement it versus how the other vendors in the world are implementing it. So we give a one-on-one mapping from a segment, which is a pure unit of parallelism in Greenplum, to a single object in S3. After that, since each segment basically has this one-on-one connection, you would go and spin up multiple threads to read that object quickly and grab that piece of object inside the buffer and start reading it. So there are a couple of things that I just mentioned, and then the two important things in that is, one of them is the buffer size, which is also called as chunk size right here. And the other is number of threads that each segment should be going and grabbing this object from. So if you want to quickly visualize it, let's assume that I have the small three segment host node cluster. Each one has two segments. Then the first segment will go and look for file number 1, and then basically goes until 6. The 7th file is again read by segment number 1. So it kind of round robins. So the ideal state would be you have files which are multiples of number of segments. So, each segment gets a distributed load and parallelized amount of way of doing this work. One more undercover, and this is the last slide I promise, which is technical enough. But then what happens is that, let's assume for P1, which is right here, it goes and fetches this file 1. Now, in fact, the file 1 is broken into file chunks, which you can define. By default, this is set to 64 MB, so that at a time, if the segment decides to open up 6 threads, which is again a default, then it does 64 into 6 megabytes of the file reading and quickly grabs that data, puts it in the buffer, processes it. If there are valid rows in your query, it takes it. If not, discards the data, goes back to the other chunks. And that's why this is fast. This is not like you get the entire dump of the file, then you open it, start reading it. There's no disk involved in this process. It's everything's kind of in the memory here. So this is the one segment look. Now, if you, I'll take questions later. So this is kind of like the technical overview. And setting it up is super easy. If you have any of the Greenplum versions above 4.3.9 and above, it's as simple as setting a protocol, and it's a one-time job actually. You just go define a protocol and you declare a protocol, and that's it. You can enable S3 readable tables as of 4.3.9, And as of 4.3.10, you can enable both readable and writable external tables. So for the folks on the call today, you can actually go and try the first part of this, which is like, read from S3, and then just go and create a protocol for read function only. After late this week, you can actually do writable and start writing it to the bucket as well. So pretty simple. This is like a standard S3 standard protocol library in Greenplum that we tapped into, and we created a new protocol S3:// and just went and implemented it. With that, since I don't know how many folks on this call are familiar with S3, but then if you need to access S3, there's a special set of credentials that are given to you from Amazon, and they are called key pairs, which is basically a secret and an access key ID that you get. And this you can go and distribute it to your team, or you can have an individual user with a single key pair, which is not a great practice, but some people tend to do that. And this key pair is given a bucket or a set of bucket for access privileges. And that's how the communication works. So as a IAM root user, if I own the Amazon account, I would go and say, Greg, Jeff, Dan gets these key pairs and set of these buckets that they can access. And to configure your Greenplum cluster to talk to such a S3 bucket, there's a quick utility that we provided. It's called GP Cloud Check. So all you need to do is go to your command line, just write this GP Cloud Check and create this dummy S3 conf file. The conf file is created with basically these 6 lines in it. It's a simple text file which basically says default, which is kind of like the profile. So it's like a default profile for your S3 credentials. You type in your secret and the access ID here. And then these are like the default values which it comes in. So this is just based on my tuning. The default is actually 6 thread num and chunk size is 64 megs. And the log level is something you can set debug, warning, info, whatever you want. And if you want to quickly check if your cluster is available to query to S3, you just do this command again, GP Cloud Check, provide the bucket that you want and the conf file that you have. And it'll go and return back with saying that the test was successful. So with this, you can actually enable your data center-based Greenplum clusters to go and talk to S3. Your cluster doesn't have to run on Amazon if you need to leverage S3 external tables. Like we have customers who run on basically not very famous private cloud, like OpenStack-based deployments, and they are able to use S3 just for storage, and then just go and spin up on-demand compute on that local, small, cheap cloud, and start putting the data right away. So this is exactly the thing that you need to set it up. After that, I'll cover this as part of a talk track later, but then it's very simple for you to go and define a DTL. You can just say, here is a readable external table. You can create a writable external table. You can just go and insert into an internal table from this external table. And all the best practices that apply to external table applies here. That means you cannot have data which has a different DDL or like a different format in a single bucket, because then this will error out. Or you cannot have a Parquet file or ORC file in this because we cannot read it today. It has to be a CSV, which is like text format, or gzip for that matter. So again, that I just mentioned, so must have the same format, new line delimited, consistent similar size, so like all the files, if you got it like consistent size, say 5 gigs or 10 gigs, it's easier for each of the segments to go and process them parallelly. Or else in some cases, the segment will just keep waiting. In an instance, if you have say 64 segment cluster and only 2 files on that S3 bucket, then only 2 segments are participating in your query. And then you shouldn't complain that, the query was slow. That is because you did not mount the data correctly. So these are the things that you need to prep up in your S3 bucket to make sure that you get optimal performance. For readable tables, you need to go to your S3 console. I'll quickly show it just after this. And you need to set the permissions as open download or view for a specified key ID, like a specified set of users that will be using it. For writable tables, you need to set it through upload and download. So if you want to prevent access for people and not disturb a data, you should just provide readable external tables, which is what most people would do. And write table only should be provided to, say, data analyst or data scientist to a specialized bucket. And then internally, you can go and replicate that data from one bucket to another. It's pretty simple as part of the workflow to define everything. Let me do the demo now, and then we can go talk about one of the design patterns that we are actually implementing at one of the customer place. I'll quickly go through what the demo data looks like. What we have done, and one of my colleagues here, Ki Shao, who's again a data engineer here, and he's really well versed with Amazon again. So he created this fake data set, which is basically all the US credit card transactions. So we have 100 million rows, all on a variety of file formats that you see here, right? So one is like a simple CSV, a single file, and we took them and we distributed into 1 gig or 500 MB or 200 MB. So for today, we'll just go with the gzip format part of it. So this is 100 million rows splitted evenly. And what we're going to do is later, we'll basically go and write it into this transfact write table as part of the demo. So just a caveat, sorry, not a caveat, as a best practice, you shouldn't have the output folder already created. So we'll go ahead and delete it. And just to prove that S3 is not always consistent, if you actually delete it, you'll still see it here. That's the catch with S3. So you shouldn't have your transactional data, like concurrent data, sitting on S3 all the time. This is for long-term storage. So this takes a bit to go and delete that folder. Okay, now let's go back to the data.
I guess that's why they call it cheap and deep. It's deep and it's cheap. It takes a while
to
be consistent.
All right, so data is pretty similar. The data is very similar to what you would see in your bank accounts if you open your bank account pretty frequently. So we already did this part, creating the S3 protocol for reading, creating the S3 protocol for writing, function for writing, and then defining the S3 protocol, which allows you to do and do this. I just have to remind folks that I'm doing this demo as part of the latest build, which is not available to the community yet. So this is 4310, which will be available later this week. So Ivan would be glad to announce that later this week. But again, this is a small cluster. If you want to take a quick look at my cluster, then it's basically running CloudFormation, and then it has basically 2 masters. So 1 master, 1 standby master, and 1 segment host with 8 segments on it, and then 8 mirrors on it. So that's why it says 16 right here. Okay, let's go back to my DDLs. So again, for the DDL, it's basically, since it's fake data, you have all the demographic and personal information for a customer. You go and create external tables, which I've already created. So if I just do -d, transfact external, this is it. You see the DDL, and if you scroll a little bit down, you would see that external location for this is on Amazon bucket that I just mentioned, or showed it to you a couple of minutes back. And the S3 conf file is sitting right here. So I cannot open S3 conf file because it contains my secret. So it's very easy for you guys to go and create it using GP Cloud Check, as I showed in the slides before. So with that, you can basically say, I want to do a select. Star from transfact external, and this probably comes back with 100 million rows. So let me kick that query in a bit. Let me go through the writable section first, and then I'll basically go and query all the heavy, or I'll go and run all the heavy queries later. So that's for the readable. Let's just do a simple select star from transfact and say limit 10. So remember what I mentioned, it has 8 segments and a whole bunch of files sitting there. So each segment, as soon as I hit this, each segment goes and picks up a file, and the operation stops when the first segment would go and say, I got the 10 rows. But in this case, since all of them are going and parallelly fetching it, ideally it would have gotten, say, more than 1,000 rows, and it only brings me 10 rows back. So it doesn't work very well. You shouldn't do speeds and feeds comparison if you're doing only limit 10. You should actually do it when you're doing millions and millions of rows, because that's when it really makes sense for you to query such an external table. So that's one. Now let's go ahead and basically do a writable external table. So I'll put in a writable external table at this location that I mentioned. Put fact underscore transfact writable. So let's see if that all actually got deleted in S3. It did finally. Okay. So I go create the table, and if I say, let's go and query this table, it should be empty. Writable. Okay, now let's see what I did, right? I created a writable table, and I tried to read from it. That is not allowed. You just said that you are creating a writable table, so you cannot read from it. So what you need to really do is define a readable table, readable external S3 table on this location for you to read it. So that means that I can use writable table for dumping the data as part of my workflow, and then create a simple dummy external table pointing to the same location. So I'm not really replicating my storage. I'm just creating one more DDL, and this just helps me from a good EBA practice also. So let's go ahead and load some data on this. Here, so I'll say insert transfact, and I'll just limit it to 50. So I'm taking it from the external table and writing into internal table. I hit this. So what it's going to do is, again, each segment goes, picks up the file, picks up some rows, and each segment writes it back to the S3 bucket. Okay, it's done. I go, let me just do a count star. Actually, you cannot, so I'll do it after the writable table. So let me go here, see if this is done. Writable is done, and it brought back gzip. As I mentioned, gzip was a default for writable. You can switch it off. So it took 50 rows and gzipped it, and each of them is basically the segment ID that it goes and writes. A segment ID and some random value that it appends to. And then the third piece, if I want to read this external data, then I would just go create something called as, transfact external writable read table. Funky name. Okay. So I created that, and now if I want to do read what I wrote before, I can just do this. Select star from that transfact external writable readable. And this, as of every demo, this actually works with 50 rows. So why not do a bigger query, right? So I'll kick it off, and I'll go back to other questions, and then we can come back to this queries. And actually, since timing is on, it's a good thing to see how long it takes. So let me do count star on the 100 million row data and see how long it takes. So remember, this is a very small cluster. It has only one segment host, 8 segments running on Amazon. The machine is R38XL, so it's 122 GB RAM and 32 cores on it. So select count star. Okay, next question, and I can come back to this query again.
Great. I wonder if you could just share some general best practices as people look to get started. What are some things that they should keep in mind so they don't maybe fall into some challenges that could be overcome if they follow these?
Sure. So in terms of best practices, I mean, this is for the S3 external table. But to get to this point, actually, let me go ahead and show you what the best practices should be for just deploying Greenplum on Amazon. And I did create some appendix slides for this. So as a prereq, just have an active AWS account with the limits removed. This is like where most of the people would actually struggle to get the limits removed in the first place. Have a key pair, have S3 credentials. We would recommend you to use spot pricing. You would save up to 80%, but remember to use this tool called Spot Bid Advisor from Amazon. That basically tells you how and when you should go and bid on some instances. And then you should have permissions to create a VPC, subnet, route tables, and everything from infrastructure perspective that Amazon cluster would need. And then this is how your workflow would be. You would go pick up the GPDB release from PivNet or S3 bucket if you have. You would either go CloudFormation route or build it into an AMI, go spin up those many nodes and get the GP init, everything done. You can work with the Pivotal data engineering team to do this automated end-to-end. If not, you can go set it up manually yourself, get the cluster running, and then this cluster, just open it up to your corporate data center, S3, or any external HDFS that you're using. So like, let's say Hortonworks Hadoop or Elastic MapReduce if you want. And then you can go and slap external tables on top of them as well, external HDFS tables. Again, as a best practice, and we really, really recommend you to follow this, is use a virtual private cloud. Don't do it on public subnets. You'll never get the performance, and your clusters would just die out after a while because of the multi-tenant traffic from the network. Use placement groups and use HVM, AMIs only, so like hardware assistant virtual machines. There is a driver from Intel and AWS, which allows you to do 10 gig network on these instances. And you can have two strategies. You can do on-demand instance store, or you can do EBS. And both of them have its own set of caveats as well as best practices when it comes to. And in terms of recommended instances, these are the ones that we highly recommend. If you go beyond this list, your cluster would still work, but you cannot guarantee any type of performance because then you're doing non-dedicated network and non-dedicated physical host in that sense.
So Amit, can you confirm that with these node types, how have you seen the network behave on Amazon? It's been pretty good, or?
It's actually good. You never get 10 gig. Trust me, you would never get 10 gig, but we have internal benchmarks that we have seen very, very good performance. Again, you cannot compare this to a data center. It's probably like 30% lesser than data center based connectivity, but it's the best you can get for any IaaS. I haven't used software, which is, hardware based cloud platform, but other than them, this is one of the best ones you would get for these instances only. The latest instance that Amazon released 2 months back is M416XL, and it has 20 gig network on it. So that is one of the things that we are testing internally, and just to see how it works.
And it says EBS optimized. What kind of EBS?
So
how much EBS bandwidth we can get on that?
So you can get up to 10,000 IOPS on M416XL. That's the highest actually that you can go for any EBS optimized volumes. The other one that competes with them is X1.32XL, which was specifically created for one of the big data vendors by Amazon.
And this might be a good time to actually insert a question from the chat, which I think was already answered, but I think it's relevant to what we were just talking about. So, I mean, how fast is S3 in terms of I/O storage, and how does this affect the queries and the best practices?
Sure. So let's go back to our query that we hit, right? So we tried to query 100 million rows. It took 62 seconds for 100 million rows, just reading, right? But it was a count start, so that's not a fair thing to do. So let's go ahead and kick off select star insert into and remove the limit. And before I do that, let me go and delete these files from the last.
This is a data load.
This is a data load, yes.
You're loading into
the first step,
the cluster locally. Right?
No. This is loading into writable external table.
Oh, okay. What about, because I think if you wanted to compare, for example, we do GPF dist, we can do, we know the benchmarks for loading into the local cluster from ETL hosts.
Right.
Do you have any sense of how fast we can load from S3?
So it's going to be, I wouldn't say significantly, but it's going to be much slower than if you compare GPF disk, because GPF disk is a dedicated parallel process that runs, right? In here, you're opening up multiple connections from one segment to S3 object, and you are limited by the bandwidth that you get from S3 to this one. So Amazon says it's a 10 gig network, but it does take time. I mean, if you're loading a terabyte of data from S3 into your cluster using external tables, it's bound to take a lot of time. I can do some more tests and get you the numbers for writable tables sometime this week. But our customers don't do speeds and feed tests on writable tables, or sorry, external tables. By definition, external tables is supposed to be, kind of a batch, near batch job that goes as part of your workflow, takes in the data from various other sources who are dumping it to S3, and then going and ingesting it into Greenplum. If you want to do something faster, go with GPF dist with the ETL store. This is not meant for near real time or, super fast.
And related to this, I see a remark in the chat about, is there, any benchmarking, or can you give an idea of kind of degree of difference between, say, using a DCA and data loading versus using from S3?
We haven't done that test yet. We have customers using this who did not use DCA actually. So it's kind of like mutually exclusive thing right now, where the customers who are using this feature and running on Amazon did not come from the DCA world for us. But fair point, we will do the test internally and get back on this one.
I wonder, considering the network performance considerations, maybe can you put this in some real world context? I mean, what are some examples of the types of workloads and use cases that this would be most appropriate for versus running, Greenplum, running in your own data center?
Sure. So let me go back. I have like a quick slide on that one. So this is something that one of our customers did, and we wrote a blog about it. Key and I wrote a blog about this back in May of this year, because we worked with these customers to actually do this workflow completely, right? So they would get data sets from external vendors every day morning. So they would get data every day and dump it on S3 through different sources. You get the data from external sources, dump it to S3. That was like one part of their batch job that would kick off every day. Once this data is ready, without prepping it, go and have the data analyst query this data using external tables from Greenplum without loading the data, because the size of this data is massive terabytes. It was ad tech data. It wasn't like, just your simple transactions. It was like basically all the web scrolling data and web crawling data that you get from ad tech companies, different ad tech vendors. Go dump it on S3, define external tables on it, and start doing exploratory data queries on it, right? Now you pick up the data of interest. So let's say with 50 different ad tech vendors, I come across like one of those data set where I would want to go ahead and create a model and operationalize it for today's thing. So take that one piece of interesting data, put it in internal tables, slap in your Tableaus, other dashboarding tools. In the meantime, you can do PLR, PLPython, MATLAB with that data set and show it to the business, but also take the output of the data and dump it back to the S3 bucket so that other downstream applications can use it. So this step number 6, we had to script it out back then to take this data, dump off this data, put it in a Unix file system, and then upload it to S3. And that's what Greenplum Engineering worked on to create this whole loop. Now this application, the data set, the output data set is actually used by their dashboard applications. Like, like a front-end application that is used by the business. So it gets into S3 and then loaded into any other framework, like say Gemfire or Redis, to go and consume it. So you're able to do full closed loop analytics without actually doing the ETL phase completely. You're just storing data. You don't have to load the data completely to even go and do the first query on it.
Right. Okay, that makes a lot of sense.
And on talking about downstream applications, I see. I'm not sure. I have a feeling I know who this is, but another Greg who's on the in the conversation was mentioning that you can imagine all of this processing with the external tables using Greenplum, writing back to the S3 bucket, then maybe taking advantage of things like Lambda, Dynamo, Redshift, Elasticsearch on the result sets there.
So I know for sure that you can load into DynamoDB from S3 directly today, and because I've done that in the past. You don't have to do anything special. You get the data into S3, load into DynamoDB directly. In Amazon, you can do it in EMR also. The cool thing would be if you're able to write it to, say, a queue, like a Kafka or something that reads from S3 continuously and goes and syncs it into operational data stores like Gemfire for that matter, right? Then in that case, you actually get a full real-time view of what's happening. Again, just to mention the fact that data in S3 is not always consistent. So take it with 1 minute or 2 minute delay, and you can get the full view of consistency in that case. So that is one of the good workflows to do. But again, S3 is used for near, I would say, batch kind of workflows only, not for like super real-time workflows today. But it's a very cheap. So 1 terabyte on S3 is just hardly a couple of dollars a month. And you can do some more tweaking. So you can enforce a replication factor of 2 as opposed to default 6, and get your price 1/3 on S3 bill. You can do all these things to make sure your bill is not high in AWS.
All right, and I'm going through the list here. You covered this, I think, pretty well in your initial pitch, but there was a question here from Sandeep about how are the S3 files mapped to segments. For example, given 24 segments and 11 S3 files, what happens? And then what is and if you might be reiterating what is the best practice for storage and transferring and loading in this case?
Sure. So quickly answering Sandeep's question, this is very similar to what I mentioned here. So in Sandeep's question, he mentioned 24 segments and lesser file than the number of segments, right? In that case, my first set of segments would go and fetch the files and others will be idle. I mean, that's not good. And that's why I keep reiterating that you need to make sure you have a lot of files on the S3 bucket. You cannot have a handful of 1 file or 2 files. Like we had one sample file there, which was 100 million rows stored in one single CSV. If I go and query that, only one segment is going to operate on that file. The other segments are going to sit idle. So what you need to really do is go back to your data set, and there are simple utilities which go and pick up the data from S3 and cut it across evenly and dump it back in the same S3 bucket. So you can use such a utility and make sure it's multiple of the number of segments you have on the cluster. So in our case, the example that we wrote, we had, so this one, we basically had about, sorry, that was the output I wanted to show then. Okay, so we had about eight files right here, right? And when we queried it, it took 60 seconds. Now in this case, when I did insert into writable table and read all the 100 million rows again, it probably took 240 seconds. Not very bad for 100 million rows on one single segment host. And if I want to query this, I go define the execute.
All right, and then I have another, it looks like a conversation here where we were talking about network I/O being actually a bottleneck with S3, and that multiple instances of S3 might be useful for getting around that. Can you comment on that a little bit?
Well,
that's a very good question. I would like to know who asked that also.
So I think I was on that conversation.
Yes.
The point is that even though there's a fixed level of processing S3 data because of the network, as you add more Greenplum nodes, each Greenplum node has its own bandwidth S3. So you can scale out your access to S3 by having more Greenplum nodes and more files.
Yep. So when you, again, just piggybacking on Ivan's response, that is correct. When you open a connection to this file, you're just maybe hitting one replica of the S3 that Amazon stores. So when you try to access the same file, 6 different times or 10 different times, you're hitting different replicas of it. And that's how there's a new data warehouse, which is cloud oriented. What they actually do is they store the data, take the real copy of data and replicate it X number of times. So the field that user gets is, S3 is very fast to query. In essence, they are just trying to create replicas and query that. So that's a very good design pattern. You can actually implement it by doing replication of this many more times and just slapping new external tables. So let's say you have 100 users who want to query the same data set. Why not go ahead and just replicate this data? If there's going to be stale data after like a day or two, just go replicate it and have those users slap in different external tables to different locations in that case. And you'll still get a super, super high speed. Because you hardly pay any cost for storing data on S3. And you can get rid of it quickly whenever you need.
And then there's a comment here from Armanta. So if there's no need for fast loading of external data, is it possible that S3 is maybe the best option for users or customers that do not have a data center?
So that's Ron, right? And Ron.
That's not right, yeah.
Yeah, no, Ron is saying, I guess the point is that the use case for S3 compared to GPF disk is what he's trying to clarify, right? So if your data is local and if data center is local, then you would use GPF disk. The use case to bring S3 in is when you want to take advantage of you want to have another place to store the data, right? So if you have, let's say you're on premise and if you're on premise and you want to store extra data but you don't have anywhere to put it, you can store it in S3 and you can still access it. Or if you're running in the cloud and you don't have, and you want to have a place for permanent storage that's not floating around on instances, then you can store it there. So it really depends on where you want to put the data more than the speed of the access.
Right. And then if you want to use the GPF disk option from your data center, you should actually go ahead with the S3 Direct Connect option. So AWS offers this product. It's like a box that sits in your data center, but gives you dedicated, sorry, my network is very bad. If you just Google for AWS Direct Connect, and they offer you direct data center connectivity, that will put your GPF disk on steroids. So it's going to be super, super fast for you to do GPF disk. If you choose not to replicate your data from your data center into S3 and just load it into Greenplum whenever you need. And as Ivan mentioned, a lot of customers want to keep the data in S3.
Yeah, and I think what Ron is trying to clarify is he's saying that we were in the chat room, we were saying that it's much slower to use S3 than GPF. I don't think we have confirmation that really is much slower. And in fact, what I would think would be that it wouldn't be the actual, that the bottleneck will probably not be the GPF disk or the S3 as much as it would be the processing of the data as it comes in. So I wouldn't be so fast to say that. I mean, I wouldn't jump to the conclusion that S3 access is going to be the bottleneck. Yeah, I mean, so Sandeep put a good point in the chat, which was if you're getting IoT data, IoT data directly going into S3 is a good use case. And then you can go and process that IoT data in an Amazon cluster, as opposed to bringing all the IoT sensor data, which could be really voluminous, on-premise environment.
Right. So if, I think Sandeep asked that question, right? So if
Yep.
Sandeep, you are able to batch that IoT data in some sizable chunks and put it on S3, that's a good use case and a good design pattern. So most of the IoT things would just go and write data every second, and that's going to be very small files, like hardly megabytes. That's a very bad design pattern for slapping external tables. So what you can do is, before slapping external tables from S3 or from GPDB, you should go and take all these smaller files and compact them into one larger file, let's say 5 gigabit object, and then go and do this. And you will get good performance after that.
All right. Really interesting discussion, super interesting demo. Ame, we really appreciate you bringing your information here. And so thank you everyone for joining today's call. We will post a recording on this quite soon. I already have people bugging me for it. So with that, everybody have a great rest of your day and a great rest of the week.